On Tuesday, we started factoring our quadratics, and the general rule is to find the greatest common factor. So can you reduce this at all? And in this one, we can take out a 2. And then remember that we need to find something that multiplies to c, so in this case 6, and adds to 7. Okay, so adds to b. And so when we look at our factors of 6, we have 1 and 6 and 2 and 3. 1 and 6 will multiply to 6 and add to 7, and so that's what we slot into our brackets. And then these give us our roots. So our roots would be x plus 1 equals 0, or x equals negative 1. And x plus 6 equals 0, or x equals negative 6. So these are our roots or our zeros, okay? So they're called two things, roots or zeros. So then if we go back and look at how we can use our factored form of the quadratic. So first of all, we can use our roots of x equals r and x equals s, and those would be numbers. So like above, there would be negative 1 and negative 6. We can find the axis of symmetry as our second step using these roots, okay, and we find the average. So r plus s over 2, or if we use the example from above, it would be negative 1 plus negative 6 over 2. So our root would be negative 3.5. Okay, and so these are called roots or zeros. Okay, and so to find the axis of symmetry, you find your average x value. Okay, and so if here are your roots, your average x value is down in the middle. Okay, and the y-intercept of the parabola is c. Okay, so when you have a x squared plus bx plus c, then c is your y-intercept. And you can find it by multiplying a by r by s. Okay, so in this example above, our y-intercept would be 2 times 1 times 6, which gives us 12. And we can see that there, so we know that's right. And then, so that finding the y-intercept would be step 3. And if we know the x-intercepts of a parabola, so if we know our roots or our zeros, we can just write our equation using the x-intercepts and the coordinates of one point. And we'll often choose the y-intercept, which remember is c, but we can choose any point. As long as you can tell what coordinates they are, as long as it's quite clear, then you can choose any point. So let's do an example here. We're going to write this in its factored form. And the general factored form would be f of x, or y equals a x minus r x minus s. So we're going to try to get into that general form. So our first step will be to find our roots. So we want to find r and s. Okay, and we just look, where is it? So we have it there and there. And so r will equal negative 1. Sorry, and these are our roots. And s equals 1. Okay, so then we write that in as y equals a x. Oh, sorry, this is over here, it's negative 3 and positive 1. So negative 3 and positive 1, it will be x plus 3 and x minus 1. Okay? We can also find the value of a. Okay, so we choose a point from the graph. I'm going to choose our y-intercept because it's very clear that this point is 0, 6. Okay, so that's the y-intercept. Again, you can choose any point as long as the coordinates are clear. The y-intercept in this case is just an easy choice. And then you substitute this point into your equation. Okay, so if we have y equals ax plus 3x minus 1, we'll put 6 equals a 0 plus 3 and 0 minus 1. And that gives us 6 equals a 3 times negative 1. And that will give us 6 equals negative 3a. We divide by negative 3 on both sides. And we'll get that a equals negative 2. Okay, and that makes sense because which way does our quadratic open? Our quadratic opens down, so we would be expecting a to be negative. And then, so our factored form would be y equals, now we know our negative, or our a, negative 2, x plus 3, x minus 1. Okay, so to write it in standard form, and remember that standard form will be ax squared plus bx plus c. All we have to do is factor out what we have. So we have y equals negative 2x plus 3x minus 1. We'll rainbow. Okay, so you make sure everything is multiplied by everything else. And we end up with y equals negative 2x squared plus 3x minus x minus 3. And then you can add your like terms, so it would be x squared plus 2x minus 3, and then rainbow this out. So you end up with y equals negative 2x squared plus, or sorry, minus 4x plus 6. Okay, so if I asked you to write something in factored form, you want something like this, okay, with 2 brackets for your x values. If I ask for something in standard form, you're always aiming to make it look like this ax squared plus bx plus c. And then to find the axis of symmetry, remember that we'll take our r and s value and find the average. So we have negative 3 plus 1 divided by 2, negative 2 over 2 equals negative 1. So axis is x equals negative 1. And let's see if our graph agrees with that. And if we just kind of roughly draw in, it does. It looks like it goes right down the middle at x equals negative 1. So let's do another example. We want this in factored form. So we're looking for y equals a x minus r x minus s. Now remember that your a could be 1, so you won't necessarily have a number. You can write the 1 if you want, but you don't have to. So let's find our roots. Our roots are negative 2 and 1. Okay, so x equals negative 2, which is r, and x equals 1, and that's our s. And so we write out what we have so far. Y equals a, because we don't know that one yet, x plus 2, because we'll do the opposite, because remember that is a, so it would be x minus negative 2, which would give us x positive 2 and x negative 1. And then just looking at this, predict what our opening up, so our A would be positive. Okay, so let's find A. So we need a point on the y-axis, or the y-intercept. So I'm going to choose, sorry, the y-axis. So I'm going to choose the y-intercept. So I'm going to choose point 0, 3. And I'm going to factor that into there to find A. So A, x plus 2, x minus 1. And I'll put 3 equals A, 0 plus 2, and 0 minus 1. Now 3 equals A, 2 times negative 1. And 3 equals negative 2A, and negative 3 over, oh, and sorry, this will all be negative because our point is negative. Negative 3 divided by negative 2. So my A will be 3 over 2 or 1.5, however you want to say that. So then to write my factored form, I'll have y equals 1.5 x plus 2 x minus 1, or 3 over 2 x plus 2 x minus 1. To find our axis of symmetry, we find the average of the r and s values. So I have negative 2 plus 1 divided by 2 is negative 1 divided by 2, negative 0.5. Quickly scroll up. That looks about right if I look for my x-axis. And then if we didn't know the value of c, how could we find it, knowing that we now have our factored form here? If you remember from just a couple pages ago, c equals a times r times s. So we can do 1.5 times negative 2 times 1, and we get that c equals negative 3. And let's check if our y-intercept is negative 3, and it is. Okay, so there are a few ways you can find everything. Be very familiar with factored form. Okay, so know that this is factored form. Know that this is standard form. Okay, know that the roots are where the parabola crosses the x-intercept, and that you can find the axis of symmetry by averaging your roots, so r plus s over 2. And then if you're not sure of the y-intercept and you know a, r, and s, then you can calculate it by multiplying them by each other. So let's do a couple examples. For each function in factored form below, determine the x-intercepts, the value of a, the y-intercept, the equation of the axis of symmetry, and the coordinates of the vertex. Okay, so now we don't have a graph. All we're working off is our factored form. So our x-intercepts are our roots, and again, sometimes they're called zeros. And so we have that if we look here, x plus 2 equals 0, so x equals negative 2, and x minus 3 equals 0, so x equals 3. And if we want our intercepts, and we can write them as points, so they'd be negative 2, 0, or 3, 0. Okay, so here's our parabola, and we know that it goes through at 3 and negative 2. To find the value of a, okay, we can look here. Since starting in factored form, a is right there, so we know that a equals 1, because there's not a number there. If there was a 3 there, then a would equal 3. To find the y-intercept, again, since we don't have the graph to look at, we can use the formula c equals a times r times s. So 1 times negative 2 times 3, and we get negative 6. So the y-intercept is at point 0, negative 6. To find the axis of symmetry, we'll take the average of the x values, or the roots. So r plus s divided by 2. And we have negative 2 plus 3 divided by 2, which gives us 1 over 2. So x will equal 0.5. And this is c up there. And then to find the vertex coordinates. So the vertex has an x coordinate on 0.5, and we know that because our vertex has to lie on our axis of symmetry. So if we plot that point into our function, because remember that y is a function of x, so where we see an x in our original formula, we can just put an x in, and we get f of 0.5 equals 2.5 times negative 2.5, or negative 6.25. So our vertex point, because we want the coordinate, would be on 0.5, negative 6.25. Okay, and I'm going to get you to try this example now by yourself. I'm going to pause it and record the solution, and then try it by yourself and then come back and see if that's what you... And just before you get started on trying it on your own, I'll just show you that I'm going to rewrite this just so it looks more like negative x and x plus 4. And then we can factor the negative out here. So we get negative 1, and then we'll have x minus 1 and x plus 4. Factored form quadratic. Try solving these. Pause the video, and then when you start it again, I'll have written the solution.